Bipolar disorder is a very severe psychological disorder which affects about 2.6% of the US population. It is characterized by alternating phases of manic episodes and very low major depressive episodes.
Yeah, Emily, why do we even need an animal model anyways?
Why do we need an animal model? We need an animal model because bipolar disorder is a very debilitating disease, and we cannot just inject people to start experimenting and try to find ways to cure disorder.
Oh,
So therefore, we use animal models to try to represent what it would look like in humans, and therefore experiment to try to find ways to cure this. We use homocysteic acid, or HCA, to induce a bipolar phenotype in rats. We injected ACA into rats into the peritoneal cavity, and this induced the bipolar phenotype. We then had another condition where we first injected ketamine and also HCA to counteract the effects of the bipolar phenotype.
The elevated plus maze was used to assess the risk-taking behavior of our HCA-treated and ketamine-cured rats. Rats were gently placed in the center of the maze and allowed to explore for approximately 5 minutes' time. Time spent on the edges may benefit exploration, but has the risk of falling. However, time spent in the safe other sides of the elevated plus maze showed no risk behavior and would be a more protected area. Thus, we would expect our bipolar HCA rats to spend more or all of their time in the covered and central part of the maze. On the other hand, rats treated with ketamine would show more bold exploratory behavior, spending lots of time on the outside of the maze looking around for potential sources of food.
This is the Morris Water Maze, and this maze was recording spatial learning behavior in rats. The way this maze works is we did 6 different trials with each rat, and we, as you can see right here, there's a platform, and each rat was placed on the platform to begin with to get acquainted with the maze and understand that there was a safe place to go to. And once we put them on there for 15 seconds, and after that we did a second trial and placed them at this visual cue with a rose on it, and they were placed in front of it and allowed to swim for 1 minute. And if they were not able to find the platform in 1 minute, they would have a second trial where they were placed on the platform again to get acquainted, understand where the platform was, and then they were allowed to swim around and find the platform. So we're going to talk about hypotheses. All right, so this is the HCA and ketamine rat, and we hypothesized that in the Morris Water Maze, they would demonstrate higher spatial learning as opposed to the only HCA-treated rats, which would demonstrate decreased spatial learning. So this is the open field test, and with this test, we are observing rats' anxiety-like behavior. The 4x4 wall is demonstrating the anxiety for rats. The center of this maze demonstrates more fear for rats because they are in an open space which can allow for predators to attack them. So if rats were going towards the center, they would demonstrate less anxiety. And if they stayed towards the ends, that would demonstrate safeness and being able to hide from predators. We use video tracking software called AnyMaze behavioral tracking software, and we hypothesized that rats with HCA and ketamine would be demonstrating less anxiety-like behavior and would go towards the center more often. And rats with just HCA would be staying towards the walls, expressing anxiety behavior.
All right. So for our first test in the open field, we analyzed the average distance traveled in the perimeter squares. So we found that rats treated with HCA traveled a significantly larger distance in the perimeter square than those pre-treated with ketamine. This agrees with our hypothesis because we expected those treated with HCA to reflect the bipolar phenotype, and with those anxious tendencies, we expected them to spend more time near the perimeter and not venture out into the middle. So they did travel a much larger distance in the perimeter than those pre-treated with ketamine, because they had less anxious tendencies, so they were willing to venture out.
In this analysis, we looked at the number of times that each group of rats exited the perimeter squares of the open field test. We hypothesized that the rats treated with ketamine would be less anxious and therefore more likely to exit the perimeter more often to enter the center of the open field. And while we did not see significant result either way, we can attribute this to the very small sample size, so we can't draw any conclusions from this analysis. The reason for this is that the wide variance in sample size between the two groups. There's only 3 rats that were HCA only, and each exited the perimeter squares exactly 3 times, leading to that extremely small error bar, whereas the 9 rats in this group had a much wider variation, which is why we did not get a significant result.
All right, if this represents our elevated plus maze, then this area right here is what we defined as the center. These walled portions are what we defined as closed, and these open areas are the open arms. So for this graph, the red coloring represents the rats that were pre-treated with ketamine before HCA, and the blue color represents the rats that were only treated with HCA. There were no significant differences in when we were analyzing the time spent in each area of the elevated plus maze. If we had a larger sample size, we may have seen significant results, but the trends that we did see reflected what we hypothesized, in that rats that were pre-treated with ketamine tended to spend more time in the open arm than HCA only treated rats, and the rats treated only with HCA spent a slightly larger amount of time in the closed arm and a much larger time in the center than the rats only pre-treated with ketamine.
A plus maze instead of the time spent in each area, and the trends look very similar, but the main difference that we see in this analysis is that the distance traveled in the center of the plus maze is significantly different between the two groups. The HCA only treated group has a significantly higher amount of distance traveled in the center group, which is kind of an indicator of the amount of times they have crossed into the center between arms of the maze. So the HCA only rats, their tendency was to cross the center more often. So they were doing this, their motion was more of like this, not going.
For our first test for the Morris water maze, we averaged all of the trials to come up with the average latency of all of the rats. We defined latency as the amount of time it took the rat to find the platform, and there was no significant difference between those treated with HCA and HCA and ketamine. Oh, we hypothesized that rats pre-treated with ketamine before HCA would have a shorter latency, and these results do not support that.
Now, in the Morris water maze, the rat has to find a relatively small platform in a big area of water. There are visual cues, but they're placed at pretty wide intervals around the circle, and as such, finding the platform might be difficult with the visual cues given. So we also use the time spent in the correct quadrant indicated by the visual cues divided by total time in the water to see if maybe the ketamine and HCA rats were getting the gist of the spatial cues faster than HCA rats, even if they weren't finding the platform with any higher speed. Despite cutting down on the noise a little bit, the numbers still did not support our conclusion that HCA plus ketamine would have a higher amount of time spent in the correct target quadrant than just HCA alone. So our hypotheses were not supported. The results varied a lot between the tests, and our sample size was small, but the trends are promising. Considering the implications of bipolar disorder for the people who have the disease, the value of this research and the need for future research is clearly important. Research with established controls of no treatment, ketamine only, and the treatments we used, as well as a larger sample size, a lot more rats, so we can actually look for these potential trends. With this kind of research, there is a great deal of potential, we think, in use of homocysteic injected rats as an HCA model and as ketamine as a potential treatment for those with bipolar disorder. Did we successfully make a model for bipolar disorder?
Can we reverse it with ketamine?
The jury's still out.
There's one thing for sure. The neuroscience department needs more funding.
Yeah. Okay. Alright, go. We test, we use homeostasis, oh my gosh. Homocystic, alright. I'm still going debilitating. Disorder. So that 3 times.
It's okay. Are you recording right now?
Mhm.
Love when you do that.
Wow, that's really bright.
You can stand next to it, right?
Yeah, you're right.
Yeah.
Okay, in this analysis,
Oh, dear, was talking. I mean,
and the ketamine ones would go like deeper in there, kind of.
Wait,
no,
The
they
opposite.
oh yeah, it was lower distance.
yeah, it was
The
lower distance.
HC1 only crossed here more often.
We're just saying that they crossed more times.
Yeah, because we don't know that they even
That's all
like
we can
went to the
say.
closed arm or the open arm. We could talk about trends. Say that the
That's true, right?
yes.
And these results neither these results neither refute.
Oh, I see what we're doing.
Yeah.
What are we saying?
One thing's for sure. Oh yeah, you
We
said one
already
thing's
said
for
that.
sure. The neuroscience department needs more funding. We built it right there. Is it going?
Oh my this is all
You
recorded.
okay?
It's all being
All right. We're good.
We're
We're
gonna
good.
do like an arm over like the
Yeah.
like
The group.
Oh
we're
my
best
God.
buds.
Okay, ready?
Neuroscience
3.
department needs more funding.
Yeah.
the neuroscience department needs more funds.
This is hilarious.
All right. 3,